All right. All right, guys. So today we're looking at section 3.1, the start of chapter 3. Hopefully, the first two chapters have gone okay for you all so far. Let's just move right on to it. Chapter 3 is about systems of equations and systems of inequalities. And we're going to start off on 3.1 with solving linear systems, and these are systems of equations, I'm pretty sure, by graphing. So you should absolutely write 3.1 solving linear systems by graphing. Okay, so the rest of it, don't write, as per usual. Now, this is what we'll be doing. We'll be determining if an ordered pair is a solution. So we'll define what a system is, and then we'll talk about what a solution would be. And then we're going to determine the solution given a graph. And then we can use calculators to find the solution to a system. All right, so let's move on. Let's get into it. So I'm not really too nitpicky about this definition of a system. So I wouldn't write it down if I was you. You'll get familiar with what a system is intuitively as we go through this, but I'll read it to you. A system of equations is a collection of two or more equations that all use the same set of variables or the same variables, right? So, like if you saw two equations like this, so if you look here, that's like one equation and that's like another equation. And what makes this a system of equations is that whatever the x is on this problem, it is also the same number as it is here. And the y value is the same y value here. All right, like the variables are tied together across the multiple equations or inequalities or whatever you're dealing with. So what's important to us is to figure out what is a solution. How have we defined what a solution to the system is? Well, any ordered pair or any values for your variables that make all equations true when you plug them in are solutions. Right? So you should write down, solution, and then like any ordered pair that makes all equations true, like when you plug them in. Okay, something like that. So just like we checked with inequalities on the last chapter, where we plugged like this in for x, this in for y, and determined if the statement was true, we're going to do the same thing here. So the problem asks, is the ordered pair 6, -1 a solution to the system? So all you have to do is plug 6 in for x and 1 in and -1 in for y, and see if it satisfies both of these equations. And it has to do both. If you plugged 6, -1 in and the top one was true but the bottom one was not true, then you could conclude that 6, -1 was not a solution to the system. Okay? So it has to be true for both of them. So let's go ahead and check both. So we've got 3, and then you're plugging in 6 for x. So you're plugging in 6 for x and -1 in for y. So you're going to have 3 times 6 minus 4 times -1 equals 22. And 2 times 6 plus 5 times -1 equals 7. So we're going to see if both of these are true. So I'm going to do the rest of the workout over here for these. So 3 times 6 is 18. And then a -4 and a -1 make a +4 when you multiply them. And is that 22? All right, is 18 plus 4 22? Well, yes, it is, so that's true. Then here, you've got 2 times 6, that's 12. And then 5 times -1, a +5 times a -1 is a -5. And so 12 minus 5, the statement is, the equation is saying that this would be 7. And is it 7? Well, yes, it is. So since when you plugged 6 -1 into both equations, since when you plugged them in, you got true statements that 22 equals 22 and 7 equals 7, then the answer to this question is yes. Is the ordered pair 6, 1 a solution to the system? Yes. All right, simple enough. Now, that's not like the only way to think about a solution to a system. Another way to think about a solution to a system is on a graph. Now, this right here, this equation, represents some graph. You could get this into like, or you could find the x-intercept, the y-intercept, connect the dots just like we did on the last chapter, and do it the same here. These are in standard form. Find the x-intercept, find the y-intercept, and graph them. Or if you wanted, you could put it into slope-intercept form and graph them. However you want to graph, but you could graph these two equations. And this 6, -1 that we have determined is a solution would, when you graphed both of those equations, it would be the point of intersection of those two lines. So when you're thinking about a solution to a system in terms of the graphs, like and how the graphs look, a solution is the point of intersection of the two lines, and you should write that down, right? A solution, maybe write to a system, is the point of intersection of however many lines you've got. So what is the solution to the graphed system below? All right, so hopefully you've paused the video and written this down, and then move on. So what is the solution to the graphed system below? So you should have written in your notes that the solution is the point of intersection. So if this is one of your lines, and this is another one of your lines, where would the solution be? Well, it's the point of intersection, and so it is right here. Right? That spot right there, that's the solution, that particular ordered pair. So this spot right here happens to be 1, 2, comma, -1, 2, 3, 4, 5. So that is 2, -5. That is your solution to your system, the single point of intersection. Okay? Now, how could we solve these if we wanted to do it graphically? All right, there's so many different ways to solve systems of equations, and the first one we're going to introduce to you guys is solving them by graphing. So you're going to graph the first equation, graph the second equation, and then look for the point of intersection. Okay, so the steps are pretty easy. You just graph each equation and then look for the point of intersection. All right, so I would go ahead and write these steps down. They're probably pretty basic, but it's good that you have the guidance in your notes whenever you're looking at homework. So one of my tips to you guys is to possibly get it into slope-intercept form, right? Like if you are a fan of slope-intercept form and that's like the way that you can graph these most accurately, then go ahead and do that. And if you can graph them in standard form, then that's fine too. It doesn't matter, so long as you just graph them. So the first example here is conveniently, or the first equation in our system conveniently is already in slope-intercept form. And I'm going to treat you guys like you know how to graph things in slope-intercept form. There's your slope, and there's the y value of your y-intercept. And so you plot that y-intercept. So you go down to 7 here, -7 on the y-axis. And then it's rise over run, so it's up to right 3. So from this point, you go up 2, and then right 3. Then up 2, and then right 3. Then up 2, and then right 3. And then you could go the other way. Instead of up and right, you could go down and left, and it makes the same line. So you go down to left 3, and that just fills the line out here. And so we've got something like this. Okay. Something like that. Now for the next one, I'm going to use this yellow to show that I colored that. I drew this in yellow. And then for the next one, I'm not going to put it in a slope-intercept form, though it's just really easy to do that. I'm going to graph this by finding the x and y-intercept. And for me to do that, the x-intercept, you get the x-intercept by plugging in 0 for y and solving for x. So I plug in 0 for y, and you get 5x equals 10, because that was 0, so that's not going to change anything. And you divide by 5, and you get x equals 2. So your x-intercept is 2, 0, so that's right here. And then your y-intercept, we've done all this before. Your y-intercept, you plug in 0 for x, so 5 times 0 is 0, so it'll just be y equals 10. And so your y-intercept is 0, 10. Hopefully this is ringing a bell. And so I plot that. So if we were to draw a line here, oh man, something like this. Maybe, man, my hand is just not wanting to do this. It might be right there. So we could figure this out, specifically by seeing what the slope between these 2 points is. We went down 10, right 2, so down 10, right 2. If you simplified that, down 10, right 2, that's a -5 slope. So it should be going down 5, right 1, down 1, 2, 3, 4, 5, right 1, down 1, 2, 3, 4, 5, right 1, down 1, 2, 3, 4, 5, right 1. Look at that. It's a perfect intersection. So with that point there. So that is your solution. This point right here is your solution. And that is the ordered pair 1, 2, 3, 3, comma, -1, 2, 3, 4, 5. So this is your solution. All right. So it turns out that, excuse me. Sorry about that. So it turns out that 3, -5 is the solution here, and that's the point of intersection. And you might be thinking to yourself, man, this is a bad way to solve these. Like, it's sloppy. I mean, you could make human errors, right, when you're graphing and connecting dots, and, maybe you could just draw your line just a tiny bit off, and then now your point's not accurate. And that is a totally valid criticism of of solving by graphing. And that's why we use tools to do it typically. So we're gonna go ahead and skip this for now. All right, we'll skip this problem for now. All right, so we're gonna do this by calculator, okay? And if you have a calculator, like a TI-84, or if somehow I've managed to get in like a TI-84s on your guys' computers through like a website or something, then these buttons, like this set of inputs, will be what you do. So there's a list here. I'm going to slowly scroll through, and you can pause the video and write them down if you would like. But I'll be going over each of these steps as well. So I'm going to scroll down here. So that was the first 5. And there is the next 5 steps. Okay. Now that's a lot of writing. I maybe wouldn't write that down if I was you. You can refer back to the video if you really need to. So, but I'm gonna solve this equation using that method. And so the first step is to solve each equation for y. And the reason you do that is because on your like TI-84 calculators, there's a y equals button right here. And all of this graph, like the way this calculator graphs equations and functions is by having them equal to y, right? Like it has to be solved for y to use the calculator, this version of the calculator. All right, so what we need to do here is solve each of these for y. So I'm going to solve for y, and I'm going to solve this one for y as well. So to solve the second one for y, you want to get the 5y by itself first and then divide by the 5. So you want to subtract x, and you'll get 5y equals -x plus 5. And then you divide by 5. And you get y is equal to, there's a 1 there, it's like 1x. So it's -1/5 x plus, and then 5 over 5 is 1. So there's your equation right now, solved for y. And then the other one solved for y, you want to subtract 2x from both sides to cancel the 2x here. and you'll get negative 5y equals negative 2x minus 5. The minus 5 stays, and then minus 2x came from subtracting 2x. And now you divide by negative 5 on everything. So what you have is y is equal to, the negative and the negative make a positive, and that's 2 over 5. So it's 2/5 x, and then a negative and a negative make a positive again, and 5 over 5 is a positive 1. So there's your two equations solved for y. All right, so I'm going to go ahead and rewrite this over here because I'll need the space when I pull the calculator up. Okay, so the next thing the steps told us to do is to press the y equals button and enter in each equation into a separate line. All right, so let's pull the calculator back out and put these equations in. So you're going to have, in parentheses, is how I like to do it. So this 2 over 5 here in parentheses, that is this 2/5. And then x is the button right next to alpha. Right, this button that's got x, t, theta, and n, that is your x button. And then plus 1. And then on the next equation, so that was the y1, that was one equation, and y2 is the second equation. So this is negative 1/5. So it's going to be, open parenthesis for a fraction, negative 1 over 5, right? X plus 1. Okay, and then you graph. There's a graph button right here. You press it. All right, so I can see one of the lines is going up and one of the lines is going down, and they intersect somewhere around here. Now the calculator can actually find the point of intersection, and all you need to do is you hit second, and then you hit this trace button up here, and it'll go into calculate. And we are looking for the intersect, right? The intersection. And so you want to go down to that spot or hit number 5 on your calculator. And it's asking you the first curve. So if you move your cursor left and right, what it's doing right now is it's moving the cursor along this curve. And all you're supposed to do is verify that it is on what you will call the first curve. It doesn't really matter which is which, but you need to tell the calculator that that's the first curve, that like it has detected it correctly. So you press enter, and so this will be the first curve, and the second curve is this one here. And that's correct. So we've got the first one and the second one. And then the guess, it's not really relevant. The guess is to help the calculator pinpoint which intersection you're looking for, because it's possible that there's more than one. But in this case, there's just this one intersection. So it doesn't matter where you guess, so long as you just press equals again. So the intersection, it says intersection, x equals 0, y equals 1. So your answer is 0, 1. Okay, so there you have it. There's your solution. Here's your homework. I should have already arranged a solution for you guys, like a calculator solution. And by solution, I mean you guys should already have access to a calculator. I should have already told you about it, right? And if you need any help, go ahead and ask me. I'll be happy to help you out with using your calculator. And you've got your homework assignment, so have at it.